All right, well, I am here representing ITG 12, and Pete Barlow is our chair, so if you have procedural questions, he's over there. But I know that you all didn't come here just for this talk. There's a lot of different codes being talked about, so I'll give a little bit of background about what I'm talking about today. So ACC is the acronym we've chosen for our code, and we're sticking to it, but it was not an easy conversation because you may have heard 3D printed concrete, 3D CP, additively constructed concrete. The industry is so young that we don't even know what to call ourselves really yet, but additively constructed concrete is what ACI is sticking with. So we are ACC. Typically, this material is a small aggregate material, less than 3/8 inch in diameter, emphasis on typically because there's a lot of different things happening. The material is usually mixed on site and then extruded in layers. That's where you get the additive from. It's adding on top of each other. Compressive strength is usually between 2,500 and 5,000 PSI, and the structural systems are all over the board. So emphasis on typically lower strength, typically smaller aggregate, but we get a lot of different things because the technology is still maturing. So structural systems, like I said, they are all over the board. There's a variety of design methods, sort of trending in one direction, but not necessarily in this industry yet. One option is printed formwork, so people are using their 3D printers to lay out concrete that stays in place, and then they'll use a ready mix truck and just have a cast in place concrete wall in between. Some folks are using a CMU design approach. That's what some of the permitted residential structures have used. So they have vertical grouted cores, and they look more like a CMU block wall if you look at the plans. Some is designed as a conventional reinforced concrete, and so they treat their print material and their infill material as a monolithic structure. And then for some of the fancier, curvy, maybe even some pools eventually, designs, they're using a parametric design approach and actually going through a finite element analysis. So across the board, people are doing a lot of different things. This image is actually an excerpt from the Unified Facilities Criteria, which is the American DoD design code. They actually give one prescriptive structural design, so folks can follow that if their printer is able to. As far as reinforcement, there's also a lot of different strategies here for reinforcement. Some folks are doing plain concrete, no reinforcement whatsoever. Some folks are using ladder, pencil rod, and rebar. You can see with all of the curves that can be introduced with this technology, and also the really kind of thin bead size, people are getting creative. Traditional reinforcement is not so easy to install here. There's been research on post-tensioning, so actually printing the entire wall and then stressing strands at the end of construction. And there's also been research on printing the reinforcement as well as the material. So extruding some sort of cable or wire along with the concrete and doing it all at once. One other area of variation is the machine itself. So gantry style printers are probably the most common. That's this image on the right. That's what we call a gantry style printer. Where the printer actually sits on rails, moves back and forth with towers, and then the nozzle is in the middle somewhere going back and forth to print the layers. But robotic arm printers are also becoming more popular, and so this one just goes in a 360 circle. Others have a gyro arm that can go in multi-directions. So if you're picking up on what I'm trying to say here, is there's a lot of variation in the additive construction industry. I almost called it 3D printing. So there's a need for a code, or at least a stepping off point for a code. But why does ACI care about this? Why are we paying attention to something that is such a small niche of our industry right now? This is the first 3D printed permitted house. This was built in 2018. This was an Icon project in Austin. You can see it's very small. It's just an ADU. but it was permitted and it's an occupiable structure. Here's another example of what folks are using the technology for. This is a bicycle bridge in the Netherlands, and this would kind of be considered a decorative or architectural application, but there's also been a lot of interest from the transportation sector in how we could use this for transportation structures. This is a printed seawall, which is becoming more popular in coastal areas, especially in Florida, and they're actually printing these more like precast, so they're going to print them in a factory and ship them out, install them on site. And this is a Department of Defense project. So these are actually barracks that soldiers are living in. I think they were just occupied within the last few months. So moving more towards a commercial application, a larger scale. Speaking of larger scale, this is a 100-home neighborhood project. It was completed last year. That's not a rendering. Those are real homes that were 3D printed. And so you can kind of start to see that the economies of scale are more beneficial for this technology, and we see projects increasing in size as companies mature and as technologies mature. And this is actually an addition to a Walmart. This was an Alquist project. You can see the little Walmart pickup sign in the corner there. Not yet ready to print an entire Walmart, but those big building owners are paying attention. So they have caught on to this technology and they're ready to start using it. So we're starting to see the commercial applications as well. So for a structural engineer or for a building official that's approached with a project like this, right now they're not really sure where to go or how do they evaluate this or how do they design it. These are some of the options that have been out there as far as code type language so far. So for the first few years of this technology, producers just needed to go get an ESR report from ICCES, thoroughly test their machinery and their material and their structural design. I went through it, takes years and hundreds of thousands of dollars, so not the easiest route to go. There's language in the IRC in Appendix AW that's actually available now. I think it was a couple years ago it came out, and it actually just references mostly UL 3401, which is for the most part a machine standard. So they're looking at machine safety in production, some material testing, some fire testing, but it doesn't really get into the structural design of the wall. So it still leaves structural engineers kind of looking for some answers. ISO and ASTM have a joint code that helps contractors set up a quality control system. Also important, still doesn't help our structural engineers. And then the UFC, I showed that drawing earlier. They actually give a prescriptive option, which is great. But if your machine can't print that, and not all machines can, you're not able to use that design either. So ACI's Committee 564, that's the 3D printing committee. They should probably change that name if we're going to use additive construction. That is the 3D printing committee that's been around for a few years now. They've been working on an emerging technology report, a few different tech notes. So hopefully those tech notes will be available soon for folks. But we have formed an ITG between Committee 564 and the Residential Concrete Committee to help get the starting blocks to a code published. So we're starting from scratch here. So it's important to note that our scope is really, really limited. Or let me back up. So WJE was contracted through a bid process to write this code for us. So they just started on this less than a year ago, and we plan to send our code to TAC by the end of this year. So that's really fast when you think about it. So our scope is really limited to start. So we've been working as a committee with the folks from WJE to develop these chapters, but we are limiting our content to residential wall systems, reinforced, single-story, rectilinear, so we're not doing any of the crazy curves or overhangs just yet. above grade walls, and then also limited to seismic design categories A and B. No shake table testing just yet. So they're working off of available research and existing codes and modifying where necessary to use for additive construction. Chapter 4 is our big design chapter. This is where we have spent most of our discussion time as an ITG. It gives you the mechanical properties, how to find them with your material, and then how to design with them. It gives load combinations, strength reduction factors, and analyses for spanning between vertical reinforcement, designing those cores, design of bond beams or lintels. Folks have different terminology for those elements as well, and then dealing with your axial in-plane and out-of-plane loading. This content will be similar to what's found in 332 and 318, as well as TMS. So we've kind of mashed them together to use what we need to come up with a coherent code for additive construction. Chapter 5 is the reinforcement chapter. So something to remember when you're dealing with a new construction methodology is that even some of the most intuitive and simple parts of our design have to be rethought a little bit, and reinforcement is certainly one of those. We have small beads, so cover requirements are going to be a little bit different, and folks are just getting creative. But again, it's all based on research that's available in the industry and our existing codes. Chapter 6 is going to be our connection chapter. So again, single-story residential walls is the limitation of our code, but we do cover their connections to foundations and to roofs. So this will be similar content to above grade walls and connections in 332 and 318. Chapter 7 is the durability requirements chapter. So a lot of this is performance-based due to the innovative materials and just having proprietary materials that are coming from different startup companies that aren't quite ready to follow a prescriptive specification. This is going to be similar to ACI 332's Chapter 5 and 318's Chapter 19. Chapter 8 is probably our second most discussed chapter as an ITG. This is the pre-qualification testing. So I mentioned earlier that you used to have to do, or without codes, you have to do a lot of testing to qualify your technology, but you still need to do a little bit. So this is covering fresh property and hardened property testing to pre-qualify a material and a machine together. So we found, and all of us on the IETG agree, that you really can't separate those two just yet. It doesn't tend to work out very well. So you pre-qualify your system and develop mixture and construction process that can be used for design and production evaluation. Just really gives you the values that a structural engineer will need to design an additive construction structure. Chapter 9 is production and placement, and in this chapter is where the on-site quality control is listed. So temporary works gives you some maximum infill placement heights, curing procedures, and what to do in extreme weather. It's going to be similar to your production and placement chapter in 332 and your documents inspection chapter in 318. Again, this is written in mind that a lot of different processes exist out there, but we want to ensure that there's good performing concrete and safety on these projects. And then chapter 10 are construction documents, production acceptance testing, and inspection. So this is another hot topic for our group, but I think we have found some resolution. What do you take on site? Are you taking cylinders? Are you taking slump? How do you measure your on-site QC with a 3D printed project? It's new territory, and a lot of folks are new to the concrete industry as well who are getting into additive construction. So we've outlined that and set some guidance and examples. We also have a commentary in our code that is pretty extensive to cover some of the unknown scenarios. So this was a challenging one, but an important one, of course, for everyone who works in concrete could understand that. So where are we right now? We met on Sunday for 3.5 hours and had a productive time. Set out a plan to submit our code to TAC by the end of 2025. And that will hopefully allow us to incorporate into 332's residential code submission. But our document is also planning to be written so that it could be referenced as a standalone document as well.